Okay, shall we start the second talk in the morning session today? Okay, so we have to have Futoshi Yagi from the Chengdu. He's going to talk about Seiberg-Witten curve from 5 brainwave with orientifold plane.
Thank you very much. Thank you very much for introduction. Thank you very much for giving me a chance to talk in this nice workshop. I'm Futoshi Yagi from Southwest Japan University, and this talk is based on the collaboration with Hirota Hayashi and Son-Soo Kim. He was the previous speaker, and Kim Lee, and also Shaolin Lee living there. And so today I would like to talk about Seiberg-Witten curves, which we constructed from fiber web with orientifold plane. It's a cool, this talk is closely related but complementary to this talk. So first, let me give us some review of Seiberg-Witten curves. So as you know, the Seiberg-Witten curve plays a central role in Seiberg-Witten theory, which gives the effective potential of 4D equals to 2 gauge theory at Coulomb phase. So the according to Seiberg-Witten theory, once Seiberg-Witten one form defined on Seiberg-Witten curve is given, then such prepotential can be is given through period integral of like integral of this Seiberg-Witten one form over this A cycle or B cycle, and by computing such period integral, we can compute the prepotential at Coulomb phase. So, giving the Seiberg-Witten curve and Seiberg-Witten one form is to give the low energy physics of the given 4D n equals 2 gauge theory. So, in this way, the finding Seiberg-Witten curve for given gauge theory is one of the very important issue in this supersymmetric gauge theory. So there are various approaches for Seiberg-Witten curves are known, and the very first one given by Seiberg and Witten is the original one. It's a field theoretic approach using perturbative computation and electromagnetic duality and monodromy and so on. And this is the original one, but not only that, there are various approaches to find the Seiberg-Witten curve. For example, there is a study of relating Seiberg-Witten curve with the spectral curve of the integrable system, or something called geometric engineering, which is to embed such setup into string theory and using mirror symmetry and using Calabi-Yau compactification and using mirror symmetry to obtain Seiberg-Witten curve. And the next is through brain setup based on Hanani-Witten type or fiber and web, and this is the main topic of my talk. And also a relatively recent approach is to start from 60 n equals 2,0 Riemann surface and compactify on Riemann surface, which gives a class S theory and obtain the Seiberg-Witten curve can be described also in this context. So in this way there are various approaches, but I would mainly focus on this, and I also comment on geometric engineering at the middle a little bit. So this brain setup approach is again discussed by Witten. So how to find the Seiberg-Witten curve based on the brain setup is as follows. So we first consider the Hanani-Witten type brain setup for in this example for the n equals to SUN gauge theory, or in this picture actually SU2 gauge theory because I wrote 2 D4 brains. So for the n equals to SUN gauge theory is constructed from 2 NS5 brain and n D4 brains extending in this direction. Like a bar is the direction of extension, and dot is the direction of not extending, like localization. And then if we would like to construct such theory, we consider 2 NS5 brain and n d4 brane suspended between 2 and S5 brane describes SUN gauge theory. So this is the Hanani-Witten type brane setup. And the point of finding Seiberg-Witten curve is to uplift this setup to M theory. And when we uplift to M theory, both NS5 brane and D4 brane becomes M5 brane. One, NS5 brane is an M5 brane which is not wrapping M theory circle direction, and D4 brane is an M5 brane which wraps this M theory circle direction. And once we find this M5 brane configuration, because everything is M5 brane, instead of regarding this as a different, many multiple M5 brane are connected, we can think this as a one M5 brane of this complicated configuration. So we can regard this as one M5 brane, and the shape of this M5 brane actually describes the Seiberg-Witten curve. If we concentrate on this 4, 5, and 6, 11 direction, which is gives the originally the configuration which gives a non-trivial which describes which correspond to the non-trivial direction which this configuration have a non-trivial configuration. So anyway, so the point is to start from brane Hanani-Witten type brane setup, uplift to M theory, and then find the shape of this M5 brane, and we find the Seiberg-Witten curve. So this is the idea of obtaining Seiberg-Witten curve. Now the talk, what I explained is actually this one. This is the original version of Seiberg-Witten curve. And in my talk, I would like to generalize this original story into two directions. One is to uplift to 5D. So instead of considering 4D n equals to 2 gauge theory, we can consider 5D n equals to 1 gauge theory, actually compact phi minus 1. And in this case, we use a 5 brane weapon. And the other generalization is to include orientifold. If we include orientifold instead of SU gauge theory, we can describe SO gauge theory or SP gauge theory. Or we can also, as I mentioned later, we can also consider SU gauge theory is non-trivial representation, hypermultiplet in non-trivial representation like antisymmetric representation or symmetric representation. And if we combine these two generalizations, we obtain 5D with orientifold, and this is what my collaborator and I did. So this is some story of this talk. So let me first focus on the uplift to 5D from 4D. The Seiberg-Witten curve originally is studied for 4D, but if we consider 5D n equals 1 gauge theory and compact phi on S1, we can also consider the Seiberg-Witten curve, because if we compact phi on S1 and choose some Coulomb phase, then and consider the algae flow and go to the IR, and then when we go to IR, all the Kautz-Klein mode are integrated out, and then at the IR, it is also understood as a 4D gauge theory, 4D abelian gauge theory. So, and for example, effective coupling of this 4D abelian gauge theory is should be determined by the input of the UV theory, like gauge coupling or mass or Coulomb phase and so on. So although originally the Seiberg-Witten theory started for 4D theory, even if we consider 5D n equals 1 theory on compact phi on S1, we can also consider the Seiberg-Witten curve. And although the IR theory is 4D, because of the effect of this integrated out Kautz-Klein mode, the detailed form of the curve is of course different from starting directly from 4D n equals to 2. And if we consider 5D n equals to 1 gauge theory, as Sonsu introduced, we use a fiber web diagram. 5D n equals to 1 SU2 superamino theory is roughly also constructed in a similar way, like two D5 brane suspended between two NS5 brane. But in this case, instead of saying two NS5 brane, we need to introduce 1,15 brane because in this case, the dimensionality of D5 and NS5 have the same object in the same dimension. So instead of saying that D5 is attached to NS5, it's more proper to say D5 and NS5 meets, and then due to the charge conservation, here we obtain some composite of D5 and NS5, which we call 1,15 brane. So, and then, so in general, in this 5 brane web diagram, P, Q 5 brane appears, which we need to write in a PQ direction in order to preserve the BPS condition. By the way, this P, Q 5 brane means the composite of P, D5 and Q NS5. And such composite should be PQ direction, and this is a condition that the whole system preserves the BPS condition. So in this 5 brane web, the NS5 brane extend to 0, 1, 2, 3, 4, 5 direction, and D5 of course extend to 0, 1, 2, 3, 4, and 6 direction. And generic P, Q 5 brane web, P, Q 5 brane extend to PQ direction as I wrote. So this is a brane setup which we use. So the how to obtain Seiberg-Witten curve from this 5 brane web is straightforward once we understand the idea of previous Witten's work. So first we have a 5 brane web which is a type 2B string theory whose configuration is summarized in this way. And as I said, in order to when we consider the Seiberg-Witten theory, we instead of considering purely instead of considering the 5D on R5, we consider compactify on S1. So suppose that we compactify this fourth direction as S1. By the way, this 0, 1, 2, 3, 4 is 5 dimension. And as I said, we consider 5D on S1. So suppose that this fourth direction is compactified. This is S1. If this is S1, we can take T duality along the direction 4, and we obtain NS5D4 setup, which is almost the same as what we studied in for 4D, but the only difference is that this fourth direction is now compactified, periodic. So the fourth direction being periodic is a difference between different from the previous example. But even if this fourth direction is compactified, it is straightforward to uplift the M theory, and the story is the same. And both NS5 and D4 becomes M5, and we can consider the shape configuration of this single M5 brane, and then the Seiberg-Witten curve for 4D equals 1 gauge theory is obtained as a configuration of this M5 brane. So this is the story of Seiberg-Witten curve obtained from 5 brane web diagram. And so this is a story of how to obtain Seiberg-Witten curve based on 5 brane web, but practically some useful method is known for given 5 brane web. So this is a more practically useful way of obtaining Seiberg-Witten curve from given 5 brane web. So the point is to find the dual graph of the 5 brane web. So original 5 brane web is written in this gray color, maybe, so the original fibrin web is this one. So we start from this fibrin web, which is now written in this gray light color, maybe, and then the dual graph means to correspond to dual graph is given by this black shape, which is obtained by corresponding this original face to dot vertex. Another face, this face is actually infinitely large region, but this I also call this region as a face, and we correspond to this dot. This face corresponds to this dot, this face to this dot, and this face to this dot. And also, each line corresponds to another line, which is also monad. This line corresponds to this line, and so on.
So it's a symmetric butterflies.
I didn't think like that.
Yeah, sorry for interrupting.
Okay. Anyway, so we once fibrin web is given, then we can write down the dual graph. And once we obtain this dual graph given in black, then each dot we correspond each dot to be monomial inside the Seiberg-Witten curve. So assigning this first this line as a w to the 0, this line to the w to the 1, this line w to the 2, and similar w to t to the 0, t to the 1, t to the 2, and then we can determine each dot to be the monomial is specified power of w and t, and then together with some coefficients in front, we can write down the Seiberg-Witten curve. So once, of course, how to determine this coefficient is one more, we need one more step. And finally, we would like to rewrite in terms of gauge theory input, like instanton factor or hypermultiplet mass, and also the Coulomb moduli. But still, the rough shape of the Seiberg-Witten curve is very straightforwardly written in this process. And also, it is known that if we use this method, independent of the detail of the shape of fibrin web, Seiberg-Witten one form is always given in this form. So we obtain Seiberg-Witten curve and Seiberg-Witten one form, so we can study the low energy physics based on this. So once we can give the fibrin web for corresponding gauge theory, then we can study low energy physics in this way. By the way, the comment is that this W and T correspond to 4, 5, and 6, and 11th direction. You see 11 is M-theory circle direction. And combination of this T is identical to 4D case, but when we go to 5D, originally this exponent x5 plus ix4 was used as a one complex variable, but in this case we use exponentiated variable because, as I said, the x4 direction is now periodic. So so x4 direction is periodic, so in order to ensure this x4 becomes x4 plus 2 pi r, such 2 pi RA, and then this periodicity is automatically taken into account if we use this variable. So using this variable is main difference, practically the main difference between 4D and 5D.
So what is RA and RM?
Sorry. RA is a radius of the, first of all, this Rm is a radius of M-theory circle. We uplift to M-theory, so we can consider the M-theory circle with radius Rm. Ra is I said that we compactify on fourth direction. So this fourth direction is also a circle. We can define the radius. So radius in the type 2A S1 is I wrote RA.
I see. So Rm is basically Copping constant of the 5D gauge theory.
Yes, that's right.
And what is the genus of this curve? Is still genus 1?
In this specific case, genus is 1. Okay, so although it's a very intuitive thing, if we consider this five-gram web, the Seiberg-Witten curve is obtained by make each line thick, like a cylinder. It's a little bit sloppy picture, but so it becomes something like this five-gram, starting from this five-gram web, the M-theory configuration is obtained by making each line thick. By the way, this circle is a 11th direction, this circle is a 4th direction. So this picture is a little bit sloppy, but still, if you imagine this picture, you can imagine that, oh, this Riemann surface looks like a genus 1. So, actually, the number of finite phase correspond to genus. Okay, thank you for question. So this is a situation. Now I explain the brain setup approach to the 5D Seiberg-Witten curve for 5D gauge theory. And although this is not the main topic of this talk, but I also would like to mention geometric engineering approach in order to explain one of the motivations of my work. So original discussion for geometric engineering approach, like obtaining Seiberg-Witten curve based on Calabi-Yau compactification, is like this. So because the 4D because the Seiberg-Witten theory originally started from 4D n equals 2 gauge theory, first try to realize such a thing in type 2A string on compactified on Calabi-Yau threefold. And consider the mirror symmetry, and we obtain type 2B string on Calabi-Yau threefold. And then, if according to them, if we take something called field theory limit, then we obtain Seiberg-Witten curve or Seiberg-Witten geometry for 4D n equals 2 gauge theory. So this was a story of geometric engineering. So the point is to consider this mirror symmetry. And by the way, although I wrote Seiberg-Witten curve, this Seiberg-Witten geometry is a complex 3 dimension, and Seiberg-Witten curve is a complex 1 dimension. But in simple cases, it is embedded in a very trivial way so that we can extract very easily for simple example. It's not always the case, but in the known example, so Seiberg-Witten geometry and Seiberg-Witten curve have a simple relation.
Why did you put a question mark?
This one?
Yes.
This is I would like to explain this.
Okay.
So, in my opinion, we should not understand this as so the word field theory limit means that because this is a string theory, so there are many string theory corrections, but what we would like to know is field theory result. So we need to take limit which throw away string correction, and we obtain the purely field theory effect. This is the idea of the name field theory limit. But in my opinion, in the modern understanding, this limit should not be understood as a field theory limit, but rather 4D limit. So this is what I would like to talk. So if we the modern understanding, we can actually correct the modify the understanding or improve the understanding of the geometric engineering. So I said that type 2A on Calabi-Yau threefold, we obtain 4D n equals to 2. And this is, on one hand, it looks natural because type 2A string theory is 10 dimension, Calabi-Yau threefold is 6 dimension. So by doing this, we obtain 4D gauge theory. This is natural, but on the other hand, we know that this type 2A on Calabi-Yau actually is equal to M theory on S1 times Calabi-Yau threefold. If we understand like this is actually the 5D n equal 1 gauge theory on S1 rather than 4D n equals 2, unless this circle S1 or coupling of this is infinitely small. So if once we consider the finite coupling or finite radius S1, we should understand this rather than we should understand this setup as describing 5D n equals 1 on S1, and this and then if we consider the mirror symmetry of this type 2A on Calabi-Yau threefold, we obtain type 2B on Calabi-Yau threefold, and then according to Eguchi and Kano, and there are other papers also, but if the mirror of type 2B on Calabi-Yau threefold is exactly the Seiberg-Witten curve for 5D n equals 1 gauge theory on S1 before taking this field theory limit. So before taking field theory limit, this geometry was already the Seiberg-Witten curve itself. Seiberg-Witten curve for 5D n equals 1 gauge theory itself. And then the field theory, the computation of taking field theory limit from this understanding, from this point of view, turned out to be 4D limit. And then taking 4D limit of this 5D n equal 1 gauge theory Seiberg-Witten curve, we obtain 4D n equals 2 gauge theory Seiberg-Witten curve. So that's why I do not want to use this field theory limit anymore. I would like to call this for 4D limit.
But didn't you also have to throw away stringy things in order to get
Yeah,
5D
that's
gauge
true.
theory?
That process is actually hidden in this local thing. This we also need to decouple gravity and so on. And this, in my understanding, this decoupling and so on is not done at this stage, but done at this stage, which means that originally we should consider compact Calabi-Yau threefold, like finite, small Calabi-Yau. But in order to focus the gauge theory effect, we decompactify the Calabi-Yau threefold and focus only on the singularity, and we consider some non-compact Calabi-Yau threefold, which correspond to focusing only on the Calabi-Yau singularities. At this stage, the string theory mode was already decoupled, so we did such a thing already around this stage, and this field theory limit was not decoupling that limit, but actually taking for the limit. So this, I think this is improved understanding from modern point of view. So this may be a little bit controversial, but I hope this is correct. And so,
maybe question. So, yeah. So the size of the S1 becomes some shape parameter of the Calabi-Yau on the type 2B side, right?
Size of S1 is
some shape parameter of the Calabi-Yau, right? For the SYZ point of view, if you do T duality. And then in that sense, you can go back to the 4D limit by degenerating the Calabi-Yau. Isn't that right?
this is sorry, very
I think you want the S1 outside the Calabi-Yau.
Right.
You want the that his S1 is not on inside the Calabi-Yau.
Size of the S1 appears in the M theory geometry already.
Yeah.
So that becomes coupled. String coupled.
But okay, then I need another S1 in that geometry. So it has to be type 2B on Calabi-Yau times S1?
well, it's a Calabi-Yau times S1 from M theory point of view. So this S1 is independent from information of this Calabi-Yau. So although, by the way, I
I see what you mean.
No,
Yeah,
to
the
the
second
top.
step, I will call it 4D. That's me.
So in other words, you start with 2A with some coupling constant, and then you do T duality along the T3, right? SYZ picture.
Yeah, it's right. Okay, yes, yes.
Right. And then a part of the coupling constant becomes shape of the Calabi-Yau, right? And then you can take a limit of that to get the limit, the 4D limit. But then it's like a.
Yeah, sounds correct. Yes. Okay.
Yeah, I think the second limit you somehow shrink this S1.
You really decompactify.
And then then you get the Seiberg-Witten curve, which is not exactly equal to the mirror curve, right?
In this, yeah.
It's true. Yeah.
That's okay, it's a 4D. So
If that's what you mean by 4D limit, then
Yeah.
I guess it's fine.
Yeah. For the limit, actually the Taylor parameter of the original.
I think you want to keep the x1 side, even you say it's 40.
This is one.
Yeah, you want to keep the side of x1 in your 40 limit.
Well, I think in this 4D limit we shrink this
Right.
one.
Okay.
So that's the X4 direction before.
X.
Yes.
Yeah, and then you T-dualize to become dual X4, which you decompactify.
Yeah. So in this brain setup, yes, this is one is of course in this brain setup, this S1 is this fourth direction. So yeah, it's a bit confusing, but I think I did some 911 flip like thing, like exchanging the rows.
X4 and X11.
Yeah, there is some. I don't remember the detail, but at some stage we can exchange the role of 2S1, and then after that we obtain this kind of interpretation. So maybe this implicit 911 flip is a source of confusion. So I'm sorry for an unclear explanation. But anyway, what I would like to emphasize is that starting from type 2A and Calabi-Yau threefold and take mirror symmetry, at this stage it's already Seiberg-Witten curve for 5D n equals to 5D Seiberg-Witten curve. Seiberg-Witten curve for 5D on S1. So this observation is already done. So in order to interpret, I would like to interpret like this way. And maybe some 911 flip or mixed up.
That changes the shape parameter to string coupling.
Yeah, I think so. Yeah. Okay. Yeah. Anyway, so what I would like to say is that the local mirror dual gives a Seiberg-Witten curve for Seiberg-Witten geometry for 5D n equals 1 gauge theory on S1. So this is one of the reasons why I'm interested in 5D gauge theory. Its extent generalization to 5D is not just like 4D is already done, so okay, let's go to 5D. It's not like that. Instead, rather, when we consider the string theory embedding, this 5D Seiberg-Witten curve for 5D gauge theory is very naturally appears. And the 4D Seiberg-Witten curve is obtained just as a limit of this 5D Seiberg-Witten curve. And also, the appearance of 5D gauge theory on S1, it also appears in another context, which is a topological string partial function. If we consider the topological string partial function on Calabi-Yau threefold, what we obtain is a Nekrasov partial function for 5D n equals 1 gauge theory on S1, rather than the Nekrasov partial function of 4D n equals 2. So when we consider and what I would like to say is that whenever we consider the Calabi-Yau geometric engineering approach and consider Calabi-Yau compactification to describe SUSY gauge theory, what naturally appears is the 5D gauge theory on S1. So this is one of the motivation why I'm interested in 5D on S1. Okay. And then up to now I have explained two approaches. One is from brain setup, and the other from the Calabi-Yau threefold, but actually they are very closely related. So once in the fibrin web, I explained this example, which is for 5D SU2 gauge theory, and we could have started also from the Calabi-Yau compactification, and this is described by toric diagram, which is described by this dual graph. I think this light square one is called the toric diagram, and the fibrin web is dual graph. Previously, I said the opposite way, but anyway. So what I would like to say is that although the meaning is really different, the fibrin web is that there is a brain here, there is such configuration of brain in a trivial geometry like our like simple geometry, but on the other hand, this is no brain, and instead it's a more geometry itself is very non-trivial, and this geometry is expressed for toric case. The geometry is expressed specified by using something called toric diagram, and this so this toric diagram gives the geometry, but the same shape appears, although the meaning is different, and then this same shape of fibrin web and toric diagram are equivalent. This is a conjecture by Leung and Bappa, and actually for special cases, these two are really connected by the chain of strings duality, which is discussed by before. So actually the fibrin web and toric diagram is the same shape. So if we have the same shape, how to obtain Seiberg-Witten curve is of course the same technique. So although the meaning interpretation is really different, the fibrin web approach and Calabi-Yau threefold toric Calabi-Yau compactification approach, how to obtain Seiberg-Witten curve practically is the same approach, at least for simple toric case or fibrin web without orientifold case. It's the same approach. So as I said, the finding the corresponding and fibrin configuration for given fibrin web diagram is equivalent problem for finding local mirror of given toric Calabi-Yau threefold. And this is true if there is no orientifold and so on. So now what I'm interested in is to find the corresponding and fibrin configuration for given fibrin web with orientifold plane. And then, as Mauricio asked, there should be also a problem on finding the local mirror of given non-toric Calabi-Yau threefold. Why I said non-toric is because I believe that the corresponding geometry for fibrin web with orientifold correspond to Calabi-Yau threefold, which is not toric anymore. And although what is this geometry? As far as I know, not very systematic method is known, but at least we know that if there is no NS5 brain and only B5 and parallel B5 is parallel O5, and just this corresponds to the resolution of T-type singularity. So the fibrin web with orientifold should be some generalization of the resolution of T-type singularity. This is my expectation. And unlike the toric case, the correspondence is not established enough. But for some cases, we know which fibrin web should correspond to which geometry. And also finding the Seiberg-Witten curve in this setup should also related to finding the mirror dual of specific class of non-toric Calabi-Yau threefold. So this can be also an interesting direction or motivation of studying this thing. So although my work is only concentrated on this brain side, potentially it should be related to the generalization of mirror, study of local mirror symmetry. So now I have explained this 5D uplift. Next, I would like to explain the generalization including an orientifold. And in order to focus on the generalization including orientifold, let's forget about 5D uplift for the moment and concentrate on 4D to 4D. So 4D set up with NS5 default to 4D set up NS5 default and orientifold, which is D404 or 06. In order to construct the 4D n equals to SO to n gauge theory, we use O4 plane. One of the methods is to use O4 plane, and the other method is to use O6 plus plane. And O4 plane, when it go across the NS5 brane, O4, it is known that O4 plus is changed to O4 minus to O4 plus again, and so on. So there are two types of constructing brane setup. But anyway, in whichever the case, it is basically based on NS5 and D4, also there are extra orientifold. So once we can uplift this configuration to M theory, we expect that this also describes the Seiberg-Witten curve. And actually this SO2N case turned out to be simple, and so one important thing is to first impose the invariance b, t to minus b, t, or b, t to minus b, t inverse. This is basically to the reflection, Z2 reflection according to the orientifold plane. So basically inverting both 4-5 direction or also this 6-11 direction depending on 4-4 or 6. And in addition, in order to take into account that this difference of the charge of this O4 plus and O4 minus, we impose that when we go to b equals to 0, b equals to 0 is actually this line, then the solution of this t either goes to 0 or infinity. And anyway, so we need to impose two things. One is the invariance, and the other is some extra boundary condition. And then we obtain Seiberg-Witten curve of this form, where this part is a polynomial in b square. This b square is, it should be the function of b square in such a way to be invariant under this action. And then we obtain the SO Seiberg-Witten curve in this form. And this one is known from the old days, and there is not very much, not very big problem. But however, Seiberg-Witten curve for 4D equals to SPN gauge theory, which is given by changing the charge of this O4 minus. Previously it was plus, minus, plus. This time minus, plus, minus. And this corresponds to the SPN gauge theory. And the computing Seiberg-Witten curve based on this, actually there was a confusion. One of the groups says that this is a result of the SPN gauge theory. And the motivation of writing like this is that although I cannot completely justify that this part, coefficient in front of t, the root of this part corresponds to the position of the d5, and at the position of O4 plus, we can treat as if there is extra d4 brane. So b equals to 0, it should be also solution, and they introduce this thing. And the other part corresponds to other 5 brane, d4 brane. So this factor b square corresponding to O4 minus is, I think, their suggestion. And the other side somehow claim that this is not okay, but plus 2 should be included in this curve. And why they did this is that when we substitute b equals to 0, the Seiberg-Witten curve reduced to this form, and this have a double root as a polynomial in t, and this is their claim. So at that moment there was two claims which are confusing, and from modern point of view, it turned out that the right hand side is correct. And correct means that, for example, if you compute the 4D Nekrasov partial function and take the leading order, the consistent potential is obtained from this side instead of the other side. So nowadays,
So the curve would depend on the moduli, right?
yeah, but so.
Could it be that there are different points in the moduli space?
Sorry.
Where's the dependence on the
moduli is depend on this p. This p is p v square is a polynomial of v square. So coefficient of this polynomial is the coulomb, or the top coefficient is actually the instance factor, and then remaining coefficient is like an.
So your point is that too cannot be absorbed into the moduli.
That's a good point. It's I also thought that this and this is actually equivalent, but it doesn't seem to be like that. Like, however you parameterize this, it doesn't seem to be equivalent to this. So nowadays, I think this is simply not correct.
When p is 0, then they are different.
That's right. Yes. So, yeah, what your concern is meaning makes sense in a sense that even if Seiberg-Witten curve looks different at first sight, it does not mean that one is correct and one is wrong. Sometimes they are related by coordinate transformation, but in this case, especially if we use this type of brain setup, the Seiberg-Witten one form is also uniquely given. So if you compute prepotential, they actually give us different result. So also in this sense, it turned out that this side is correct nowadays. So the point of this claim how to obtain this Seiberg-Witten curve is actually this double root condition. So the interpretation is that the curve have a double root. So originally we have an O4 plane and 2nx5 plane, and the charge changes in this way. But when we uplift to M theory, what happens is that O4 plane is actually uplift to something called OM5 plane, which is like a kind of orbifold fixed point, what we do. And this 2nx5 plane is actually combined to 1 and attached to this OM5 at one point. So this is a condition of double root at v equals to 0. So this line is v equals to 0, and then there are two solutions at generic v, but at v equals to 0, these two solutions collide and becomes identical, and this is a double root. So this is a boundary condition which we need to impose at the position of OM5. This is their claim, and nowadays it is believed to be correct procedure. And also, they instead of using O4 plane, we can also consider O6 minus plane. And also, even if we use this O6 minus, we also obtain the same thing, and we obtain this Seiberg-Witten curve for SP and K0. So now, this is a point of introducing orientifold plane. And finally, I would like to explain my own work in remaining 15 minutes. So now I would like to explain this side. 4D gauge theory SOSP with a 5D SOSP, or SU with another non-trivial representation. So 5D Seiberg-Witten curve for 5D n equals 1 SO2 and gauge theory on S1. This SO uplifting to 5D was from 4D to 5D was relatively straightforward. And in addition to this invariance, we impose extra boundary condition. At this time, not only previously I said v equals to 0, this time I say v equals plus 1 and minus 1. It is because O5 plane is split into two O4 plane in the T duality, so we have two positions. And then we obtain this type of Seiberg-Witten curve based on this boundary condition. And actually, this Seiberg-Witten curve I computed by using this O7 plus plane, but especially in this specific case, the same thing happens even if we use O5 plane, and this one is already done very long ago. So although this time I use this O7 plus plane, at least in this example there is not much difference. But when we consider the SPN, there is the confusion revives again. Previously I said that there was a two confusion, this versus this, and I said that this is correct. But based on this curve, almost the same author uplift to 5D gauge theory based on this idea of this Seiberg-Witten curve. But once we notice that this is not correct and this is correct, the 5D Seiberg-Witten curve based on this is also very doubtful. And then I thought that we should, in order to get a correct 5D SPN gauge theory, we should uplift 5D theory based on this idea. And this is what my collaborator and I did throughout these three papers. One is only SP1 from O5 and generalized to SPN and including other ingredients. And SPN from, instead of O5 but from O7 is given in this paper.
I have a question.
Uh-huh.
So can these two curves on the this part can be related by reparametrizing the
this is what this.
I mean V prime.
This and this. I said that they are not related by reparametrization. But
you don't include the U prime.
new parameter.
Related to the compact structure parameter or the Taylor parameter.
Taylor parameter thing is like gauge theory parameter, Coulomb moduli or instant factor and so on is included in this P. P is a polynomial and coefficient include such gauge theory parameter or Taylor parameter.
And can say these two curves related if you redefine the.
Even if they redefine, I believe that they are not equivalent because I said that this is nothing previously, but especially because they both are obtained from Fibrenberg or brain setup, and then Seiberg-Witten one form is uniquely given, and by using Seiberg-Witten one form, given Seiberg-Witten one form, we can compute the prepotential explicitly, and they give different prepotential.
No, I mean because if you the two Taylor parameters are different, you cannot get the same answer.
I see. Even I feel, but
Line transform is different.
You redefine the Taylor parameter on the two sides. Sorry, that's a
Still line transform.
But there, especially for this pure case, there is not much degrees of freedom. So in a sense that the Seiberg-Witten curve includes instant factor, but the remaining is like a Coulomb moduli like U, and then we rewrite this U into A by A cycle integral and so on. So even if you redefine U, it doesn't change because after all we remove such U and rewrite in terms of A.
Yeah, if you think U is proportional to A in some sense.
Oh well, in the classical limit.
Probably U plus 1 is
No, well, Taylor parameter, I think you are talking about A model side Taylor
yeah,
parameter.
but here
That is correspond to A, and A and U is very non-trivially related by mirror map. So, but anyway, so my opinion is that even if you parameterize any gauge theory parameter and any Seiberg-Witten variable, they are not equivalent. And actually, the 5D uplift version is also studied in this paper, and they use this paper is actually computing prepotential based on the Picard-Fuchs equation, and then anyway they computed the prepotential and compared with the leading order of the Nekrasov-Paschen function that is computed from lower formula, and then this side is consistent with the Nekrasov-Paschen function, and this was not. So their paper also claims that this curve and this curve is not equivalent, even if you reparameterize things, and they are really inequivalent. So I think this is a like, oh, okay. Anyway, if you yeah, oh, okay, yeah. Anyway, so reparametrization is always a subtle issue in this business, but even if we take into account, I believe that it's still inequivalent. So nowadays, I think I claim that we should believe this side, and it's consistent with Nekrasov partial function. And what I did is actually Seiberg-Witten curve for 5DSP and S1 from O5. This is one of the issue. And then again, we impose the invariance and the condition of double root. In this case, we impose the that polynomial in T should have a double root, both at +1, w equals +1, and w equals -1. And then the double root, because this coefficient is 1, the solution of the double root can be either t equals 1 or t equals -1. And both t equals to 1 correspond to this case. So if SP odd with discrete set angle 0 or SP even with discrete set angle pi is described in this Seiberg-Witten curve. And the remaining case is described in this slightly different Seiberg-Witten curve. And they are slightly different because the boundary condition is, the condition is that w equals to 1, t equals to 1, but w equals -1, t equals to -1. This case, both t equals to 1. So because of this subtle difference, there are two different choices up here. And these two different choices correspond to two different discrete set angles. So this is also very nice observation that to impose this boundary condition. By the way, going back to this case, in this example, they didn't even think, didn't specify the discrete set angle. So, and this curve does not agree with neither of the discrete set angles. This is the plane. And we can also do the similar thing based on O7 plane, which is almost the same idea, but the detail of what kind of Z2 action should be imposed is different also. And also in this case, we should keep double root to be both t equals to 1 and w equals to ±1. But instead, we do not impose that depending on the position of this node, you can even change the position of this node to be here or here and so on. By the way, this graph is a dual graph of this one, and the position of this corresponds to the power up here as a power of here, and depending on this power is even or odd, the different discrete set angle is distinguished. So there is a small difference between using O5 and O7, but both gives equivalent Seiberg-Witten curve. This time, the result of O5 and result from O7 is equivalent up to coordinate transformation. And we can also add flavor to 5D n equals 1 P theory based on O7 minus plane. And then the idea is basically the same, so I just wrote down the result. So it is also straightforward to add flavor. Or not from now on, because how to obtain is more or less similar, like imposing the D2 invariance and add extra boundary conditions. So I just write down simply the result. So impose the Z2 invariance and also the boundary condition. We obtain not only SO but also SU and with hypermultiplet and symmetric representation, and flavor can be also obtained by using this technique and by using O7 plus, or if we use O7 minus, we also obtain the Seiberg-Witten curve in this way. This time there is some small additional constraint, not only invariance. And in this case, we have a degree 3, we obtain degree 3 polynomial. So we have a degree 3, three solutions for t. And the condition is that we should have a triple root at w equals plus minus 1. So this is a natural generalization compared to the SPN case. And further technical condition, mild condition is also imposed in order to really determine things. So there is some small generalization and small correction based on compared to the previous one when we generalize to slightly more complicated case, but the idea is more or less the same. So if we use O7 minus, we can also compute the Seiberg-Witten curve for SUN with hypermultiply and antisymmetric tensor representation and flavor. And and then the observation, which is related to Sonsu's talk, is that the Seiberg-Witten curve for 5dn equals 1 SPN gauge theory with H flavor is identical to Seiberg-Witten curve for 5dn equals minus 1 gauge theory if we tune the mass parameter to be like this way. By the way, this mass parameter m is an exponential of mass. So equals to 1 means massless. Equals to minus 1 means there is a phase like pi r. And the similar observation was found also in this Seiberg-Witten curve for 5dn equals 1 SUN with 1 symmetric plus 8 flavor is identical to Seiberg-Witten curve for 5dn equals 1 SUN with one symmetric tensor if we tune the mass to be like this way. So interpretation is that at least at the level of charge, O7 plus is the same charge as O7 minus plus 8d7, but the same charge actually, object with the same charge existing at somewhere in the fibrin web means that the effect of such object to the remaining fibrin, M fibrin, becomes identical, and finally the Seiberg-Witten curve is the same. So although this, by the way, I'm not really saying that O7 plus consists of O7 minus plus 87. If I say like that, probably it's a wrong statement. But at least at the level of Seiberg-Witten curve, and also actually at the level of index or Partial function, this relation holds, and we can compute the such object constructed from this by decomposing like this way, and tuning the location of this O7 minus to be identical to the position of this O7 minus, and then we obtain the remaining curve. We can obtain the Seiberg-Witten curve of the partial function based on this O7 plus can be obtained by decomposing like this way. So finally, I also computed the non-Lagrangian theory realized by fibrin web with O7, and this is actually exactly the same theory, like local P2 plus adjunct or local P2 plus symmetric. And Sonsu said that I will explain, but actually I also so anyway, but I would like to emphasize that this we know how to compute Seiberg-Witten curve, even if we have O7 plus. So we can compute like this first and second condition is a condition coming from the existence of O7 plus, and the remaining is the known method which whenever we have this kind of shape, like a single 7' binds the multiple fibrin. In this case, we know how to deal with it. This is kind of a generalization of class S theory, how to obtain Seiberg-Witten curve from class S theory. This is a 5D uplift of such idea, and then we obtain Seiberg-Witten curve. Once, even if it's non-Lagrangian, once we have a fibrant web, possibly including orientifold plane, we can still compute the Seiberg-Witten curve. And then we can compare with this computed local P2 plus adjoint and S5DSP1 with 7 flavor. With tuned mass, we check that the solution of the double discriminant is identical. Actually, there is some subtlety that we need to factor out the physical part, throwing away the non-physical part. But anyway, so this double agreement of the solution of double discriminant equals to 0 indicates that these two Seiberg-Witten curves are equivalent. So the conclusion is that for fibrant web with all planes, the Seiberg-Witten curve is obtained by imposing C2 invariant plus further constraint, and this further constraint played a key role, especially we consider the SPGH theory, or 7 minus, and non-trivial relation between two Seiberg-Witten curve is obtained by this relation, and this technique is applicable to non-Lagrangian theory like local P2 plus adjoint and so on. Yeah, so thank you very much.
Questions?
Basic question. So for the 07 brains, do you have an M3 corresponding object?
Actually, I didn't think very seriously, but yeah, I believe that there is such counterpart of, or if we say 07 plus, it decomposes into 06 plus, and then, sorry. Yeah, and we uplift this 06 to M theory, and I think precisely we should consider like D6 or 06 when we uplift to M theory is more like geometry rather than
some
object.
kind of
So
gravitational monopole.
yeah.
Rather you have this kind of thing for orientifold.
Yeah. So sorry. Yeah, what was it?
Yeah, because in general for D6, it's affixed to some KK monopole.
Yes.
I'm just wonder whether there's some gravitational solutions for orientifold as well.
Oh, I think so. Well, I don't know the detail, but I think the original discussion was based on such thing, like at least. Anyway, I think so. And originally the inclusion of 06 is based on the corresponding geometry. Should be like this, and then it's the similar discussion as introducing D6, analogous to introducing D6. 06 was also discussed like before.
In the 90s?
Sorry?
It was discussed in the 90s. Is it?
I think so. Yeah, because study about this 06 uplift of this 06 to M theory and finding Seiberg-Witten curve, this kind of study was already done in a relatively for example, no, it's not. Sorry, but for example, this 1997 they are discussing. Sorry, this is 06 minus, but they also did 06 plus, and at this stage, I think the uplift of this 06 to M theory was known, at least in the context of it. There was enough information to find Seiberg-Witten curve.
Any other questions?
Will anything interesting happen if you apply both the 04 and the 06 plane on top of each other?
Both 04 and 06. Yeah. I think there is such a thing, and actually there is also. I think yes. There is. I cannot tell immediately, but there is also such setup, and
You'll get an OM plane on the side when you have these two together, and I think the gauge group turn from SP to SU again.
probably yeah. I have seen such thing in. Sorry, I cannot tell very clearly, but I know there is such brain setup was studied, and I'm sure that Seiberg-Witten curve can be also computed in this way, but possibly the brain setup itself and the corresponding gauge theory, I think it's what corresponding gauge theory I think is already studied. Maybe you know, but I'm not sure whether Seiberg-Witten curve is also studied in that case. So possibly it's interesting to consider Seiberg-Witten curve in that case, and I don't think it's that difficult.
So when orientifold is involved, what is the argument that there is still a Seiberg-Witten curve? So in general, there are more general for the
even if there is a
theories.
well, even if there is a orientifold, this what we are looking even if we have for example even if there is something orientifold, what we are looking at is a configuration of M5 brain uplifted from NS5 and D4. So we can, after all, we are describing the shape of this M5 brain coming from this, then this becomes a Seiberg-Witten curve. Is it?
Well, I'm not sure. So like 08 cannot be lifted to M theory, right? For example. So I'm worried about lifting.
But I didn't use 08, so.
So probably 06 will have similar problem, right?
06.
So only this plus bunch of D brains can be lifted, right? And in M theory you cannot separate them. So that could be an issue, right?
Well, you think we can uplift 06? I think
I'm
06
not sure. So the same problem for 08 could happen here, right?
Yeah, I didn't think about 08. At least 06 have not much problem. For example, D8 is also a problem, have a problem to uplift M theory, I think.
I think his question is, I think
Yeah,
06
so
with some D brain has a D6 may have M theory uplift. Does 06 itself has uplift?
But I think you are making a good point. So like 08 and D8, they both have problem, but a combination would work. But then since D6 is okay, so maybe 06 is also okay. I don't know.
Is it possible to F or G or E type of gauge groups?
Well,
G,
yes. At least I know G, and E and F. For G2, 5DG2 fiber web for 5DG2 is already known.
Okay.
So although
What is the reference? Can you tell me the reference?
actually,
What's
okay.
the-
What happened to G2, you can invert it to the, what is that?
SO7 is
SO7 with one
spinner.
spinner, and then you do a mixing, and then you give rise to G2.
Okay,
G2 can be embedded to the,
fixing.
sorry?
The idea is going to do the fixing. We start from some conventional framework and do the fixing.
Yes.
But SO with spinner is not that conventional. It's we need to know how to.
Yeah, so spinner you can introduce for the SU gauge theory of the brain lab. And then you do the mixing of this spinner method, and then give rise to the G2 gauge theory.
Yeah.
But F4 and the E6, E7 and E8, but for the time being, we don't know how to do it in the five-brain web. But if you extend the five-brain web with something called the trivalent and then quadrivalent, which is some sort of expansion of this, it's like a thinking diagram. And what you use as a brain, but it's not a type 2B five-brain web, but you can still like mimic the structure of the thinking diagram, and that brings the trivalent gluing of the web or quadrivalent gluing the web, and that is a way to realize the equational engagement.
Has this already appeared in the literature or?
Yes.
Yeah.
But in the case of E, isn't that have they uplift on the Minahan and Chomsky theory?
That's the Flavors method, but he's talking about gauge.
Sorry. Any other questions? not, let's thank the speaker. For lunch, again, the students will help. And yesterday, as you can see from yesterday, the level canteen is that one. Does not change it from yesterday. Anyway, so they will help you guys.